Hello everyone, I am Lakshmi Pandey. I am a PhD student in the Human Computer Interaction Group at the University of California, Merced. I am going to present my work with Azhar Alizadeh and Professor Ahmed Sabir Arif titled Enabling Predictive Number Entry and Editing on Touchscreen based mobile devices. We found out that users often enter numbers on mobile devices, but the current practice of working with numbers involves multiple apps and performing many steps. Most users use third party apps such as calculators, unit converters, or web browsers for number entry and editing. For example, to convert currency, most users use a web browser. They first select a value to copy it, paste it on the web browser, and types in the currencies, perform a web search to see the target value, select the value to copy it, navigate to the original text input area, then finally paste the value. This process is time consuming, tedious, and distracts user from the task at hand by forcing them to switch between different apps. Nowadays, almost all virtual keyboards have suggestion bars that present the most probable next words. But these suggestion bars remain blank when entering numbers. In this work, we use this unused real estate of a suggestion bar to facilitate predictive number entry and editing. We developed a predictive system for numeric values that work in real time and does not require the use of different apps to perform the most common actions with numbers. For this, we first collected the most frequent tasks performed with numbers in an informal survey. Then, based on the findings, we divided interaction with numeric values into two categories. First, entry, where users enter new values such as date, time, amount, or equations. Second, editing, where user edit pre-entered numeric values such as change an amount to different currency or perform arithmetic operations on existing values. Finally, we developed various predictive features to facilitate both number entry and editing. The first feature enables numeric suggestions based on generic text-based queries on a database. For this, the system uses a semantically informed, context-aware language model that can understand natural language to retrieve necessary information from the database. For example, when the user types, "Let's go camping coming weekend," the system fetches the date of a coming weekend and displays it in different calendars. User then can tap on a suggestion to enter it. The second feature displays suggestions by detecting numeric values using regular expression and by classifying each value based on a set of rules. Specifically, when the system detects a number with a specific prefix, suffix, or format, it classifies it as particular type of value, such as date, time, or unit. For example, when the user types $12.4, the system classifies it as currency since the dollar prefix is most used with currencies, and then displays the entered amount in different currencies by fetching the most current exchange rates from the internet. Tapping on a suggestion replaces the amount with the suggested value. The third feature suggests autocompletion. For this, it detects the nature of a numeric value as the user types based on the context of the conversation, separators, and symbols, and then suggests the next probable numbers, words, suffixes, and prefixes for the input. For example, if the system detects a number with separator like colon, it classifies it as time since a colon between numbers is commonly used in time. And then it displays the entered value in quarter hour increments. Tapping on a suggestion auto-completes the remaining part of the input. The final feature detects arithmetic operation signs like plus, minus, division, multiplication between numbers to perform the respective operations and suggests the result in various formats. For example, when the user types 15% of $25.55, the system shows the result in different units. Tapping on a suggestion replaces the value with suggested amount. The proposed system also facilitates editing numeric values. To edit an already entered value, the user taps on it to see all probable autocompletion, conversions, arithmetic operations using the same features used for number entry. For example, here the suggestion bar shows predictions based on the last entered word bag. But when the user taps on the numeric value 15 kg, the suggestion bar displays the value in different units. Tapping on a suggestion replaces the entered value with the selected value. We evaluated the method in two user studies. The first study compared the performance of the predictive system with Google Quick Answer, which is the most common method to acquire numeric values. 12 volunteers aged 23 to 28 years took part in the study. In a study, participants performed 10 tasks with each method, including digit and symbol entry, metric conversions, arithmetic operations, and numeric answers of text based queries. After their study, they all completed a questionnaire that asked them about the predictive system. In the study, the predictive system was 46% faster, required 69% fewer actions, and 100% accurate result than the Google Quick Answer. It also required 72% fewer corrective actions, saving roughly 64% in correction time. Besides, all participants felt that predictive system improved their entry speed and accuracy. We then conducted a second study to explore number editing. It used the same procedure as the first study but asked participants to edit all numeric values in preloaded paragraphs. In the conventional condition, participants were asked to replace the existing values with the values presented in a sheet of paper, while in the predictive condition, they were asked to pick the intended value from the suggestion bar. 12 new volunteers aged 19 to 36 years took part in the study. They edited 3 short paragraphs containing 6 different types of numeric values with each method. They all completed a questionnaire that asked them about the predictive system. In the study, the proposed method was 61% faster and required 92% fewer actions than the conventional method. It was also 85% more accurate. Besides, all participants felt that the system improved their number editing speed and accuracy. To summarize, we enabled predictive number entry and editing on mobile devices using text-based querying and regular expression. Empirical evaluation showed that the system significantly increases number entry and editing, speed and accuracy, and reduces the number of actions needed per task and the time and effort needed to correct errors. Subjective analysis revealed that most participants found the method faster, more accurate, and easier to use. I would like to thank ACMW and CHIIR for supporting this work through travel grants. Thank you for your time. I am happy to take any questions you may have. I also invite you to visit Ask Questions on our social media channels. Thank you.